See, Standard 10th Maths, Chapter 7, Mensuration, Exercise 7.4. First sum, an aluminium sphere of radius 12 cm is melted to make a cylinder of radius 8 cm. Find the height of the cylinder. See here, the sphere, the solid sphere whose radius is 12 cm is melted and recast into a cylinder. So the cylinder has two units, radius and height. Here the recast cylinder is radius 8 cm. Question, you have to find the height of the cylinder. So first let me collect the given data. Sphere and the cylinder here. So the sphere radius is r. Let me take this is 12 centimeter. And also they are given the cylinder radius. We cannot take the same r. Let me differentiate this and take as r1. r1 is equal to 8 centimeter. And see the question, find the height of the cylinder. You have to find the height h1. So let me take for the cylinder r1 h1. You keep this r. So in the melted case, we use the volume. So volume of the cylinder is equal to the volume of the sphere. So volume of the cylinder is equal to volume of the sphere, because one sphere is melted and recast into the cylinder, so both their volumes will be same. So what is the volume of the cylinder? Pi r squared h. Here I have taken r1, so take r1 and here h1. Volume of the sphere is 4 by 3 pi r cube. So you can take cubic units. Both are cubic units. So don't substitute for pi. Keep pi as it is. What is r1? 8 into 8 into h1 is equal to 4 by 3 pi into r is 12. 12 into 12 into 12. So h1 is equal to 4 by 3. You write this as it is, pi into 12 into 12 into 12. You take all these terms on the left side to the right side. Put the divider line here, pi, and 8 comes here in the denominator, and also this 8. Cancel the common terms, 8 cancel here. 4 2s are 8. Then 4 3s are 12. 2 2s are 4, and this 2 here goes 4 times, 4 here it goes 3 times. So denominator term all gets cancelled, only numerator term 3 into 12. So h1 is equal to 3 into 12 is 36. The unit is, all the units are given in centimeter. So I write the h1 is also centimeter. So question is, find the height of the cylinder. So height of the cylinder is equal to 36 centimeter. See, water is flowing at the rate of 15 km per hour through a pipe of diameter 14 centimeter into a rectangular tank which is 50 meter long and 44 meter wide. Find the time in which the level of water in the tank will rise by 21 centimeter. So in the first half, water is flowing at the rate of 15 km per hour through a pipe. Pipe is cylindrical shape, cylinder of diameter 14 centimeter they given. So the flowing of water through this pipe gives you the height of the cylinder. So this 15 kilometer per hour, we have to take height of the cylinder. First let me take the figure. Cylinder, the diameter they given 14 centimeter. They given the diameter as 14 centimeter. So radius is half of this is 7 centimeters. See, and also look at the units. See, all the units are in meter. So let me convert into meter. So that is, I divide by 100. 7 by 100 meter. So radius of the cylinder is 7 by 100 meter. So the speed of this pipe becomes the height of the cylinder. The height of the cylinder is equal to 15 kilometer per hour. So convert this also into meter. So 1 kilometer makes 1 kilometer is equal to 1000 meter. 1000 meter. So this become 15 into 1000. So 15,000 meter per hour. Meter per hour. This is the height of the cylinder. Come to the next figure. Rectangular tank. So the figure is rectangular tank. Long. Length is 15 meter. Wide is, breadth is 44 meter. And also find the time. You have to find the time to make the level of water rise to 21 centimeter. This is height of the rectangular tank. So rectangle, just write rectangle. Length, breadth, height, everything is given. Length is 50 meter. Height is, breadth is 44 meter. Height is 21 centimeter. So you take this as meter. 21 by 100 meter. Okay. First you find the volume. So the volume of the cylinder, pi r squared h, cubic units. So pi is 22 by 7. R is 7 by 100. 7 by 100. H is 15,000. Meter cube. So meter cube, all the units are in meter. So this is meter per hour. Meter cube per hour. This much of the water comes out through the pipe. In 1 hour is this much of meter cube. Next you find the volume of the rectangle. V is equal to LBH formula, cubic units. So L is 50 and B is 44 and H is 21 by 100 meter cube. Just meter cube. Now time taken. Time taken is equal to, the bigger one is volume of the tank. Volume of the tank divided by volume of the cylinder. That is, volume of the water comes out from the cylinder in 1 hour. So volume of the tank, you write the units. 50 into 44 into 21 by 100. So put the denominator line by 100. Let me write here. Okay. Now volume of the cylinder, pi is 22 by 7. Write this 7 to the numerator. Denominator terms goes to the numerator. 7 by 100. So 7. So here denominator here 100. Then 7 into 100. Then divided by 15,000. 15,000. So 100 gets cancelled here. 7 gets cancelled here. This 22 goes here in 44 2 times. And then 2 zeros you cancel here. And one more 0 here I cancelled. Then 5 threes are 15. 5 threes are 15. Then 3 sevens are 21 and this 7 gets cancelled. So denominator term all gets cancelled. Only the numerator term has 2. So meter cube per hour, that is hours. Time is in hours. So the question, the time taken to raise the time taken to raise the water level, to raise the water level in the tank, by 21 centimeter is equal to 2 hours. This is the answer. See this third sum. A conical flask is full of water. The flask has base radius r units and height h units. The water from the flask is poured into a cylindrical flask of base radius xr units. Find the height of water in the cylindrical flask. Here two solid figures we have. One is, first flask shape is conical flask. Next is cylinder. Write them separately. Cone, cylinder. The cone radius, the radius is given as just r units. Height is h units. They mention in the alphabets. And the water full of conical flask is poured into the cylindrical flask whose radius, let me differentiate this radius r from the cone. I mentioned this as r1. r1 is equal to hr units. Find the height of this cylinder, h1. You have to find, question mark. But in this case, the volume of the cylinder is equal to volume of the cone. Both their volumes are same. So volume of water in the cylinder is equal to volume of water in the cone. Volume of cone. Just mentioned volume of cone. So cylinder volume is pi r squared h. I want to differentiate this r1 squared h1. This is 1 by 3 pi r squared h. So replace pi, you keep as it is, r1 as xr the whole squared. xr the whole squared. This is h1. You write this as it is, 1 by 3 pi r squared h. So pi x squared r squared h1 is equal to 1 by 3 pi r squared h. I want to find h1. So you write this as it is, 1 by 3 pi r squared into h. Bring this to the denominator, pi x squared r squared. h1 you have to find. So pi gets cancelled. This r squared gets cancelled. That's all. So the remaining terms are h by 3x squared. So this is h1. So when you transfer the full of water from the conical flask to the cylindrical flask, the water raised in the cylinder is at the height of h by 3x squared units. Just units. So height of the water in the cylindrical flask is equal to h by x squared 3x squared units. h by 3x squared units. Thank you.